Okay, so here we have a simple rational function. What can you tell me about the graph of this function?
Got a 0 at 3.
The denominator is 0 at 3, but the function isn't. What happens to the function when x is 3?
Undefined. It's undefined.
It's undefined, so what happens near x equals 3?
Vertical asymptote.
Vertical asymptote, right? So, in some sense, it acts, at least near 3, like the 1 over x graph shifted 3 units to the right. It also vertically stretched because this thing has a value, right? Okay, so we want to kind of look at that. Now, the easiest way to look at it, or maybe the easiest way, is do a long division. Okay? So, we do x minus 3 into x squared plus 3x plus 7. And we get x here, it gives us x minus x squared minus 3x, which gives us 6x plus 7, so it's x plus 6. And then we're going to have 6x minus 18, and we have a remainder of 25. And from this we conclude, if I did this right, let's hope I did, that this therefore equals x plus 6, because that's what we have here, but then we have that remainder of 25, so it's x plus 6 plus 25 over x minus 3. Okay? So we can graph x plus 6. That's a tough one, but I think you can manage it. Okay? And we can graph 25 over x minus 3. Just take the 1 over x graph and stretch it vertically by a factor of 25, and then move it over to the asymptote at x equals 3. Okay? So let's do that in a little detail to make sure you understand it. Okay, so first of all, we're going to graph x plus 6. What's the easiest way to graph x plus 6? Well, I would find it's x and y intercepts. Okay? Now, I'm not going to go through the details of that because you should know. If you don't, ponder it a little bit. But here we have minus 6 and 6 on the x and the y axes. And these are the intercepts, because when x is negative 6, x plus 6 is going to be 0. And when x is 0, x plus 6 equals 6. So it's pretty easy. So we have a straight line. So here is the graph of y equals x plus 6. Now we need to look at the graph of 25 over x minus 3. Okay? So to do that, let's just kind of fiddle around with that on a different set of axes so we don't clutter this one up, because all I want up here is this function and this function. Okay? So first of all, my graph of 1 over x, it looks like this. Okay? And I got the 0.11 on here someplace. Now, what do I have to do to get the graph of 25 over x? What has to happen to this graph to give me 25 over x?
Vertical stretch.
Have to multiply all the y values by 25, vertically stretch it, right? Well, that's going to take this point and move it up here somewhere. It's going to take this thing and make it a whole lot steeper. So I'm going to kind of fudge it a little bit. I'm going to say, okay, I'm going to relabel it. So the graph of y equals 1 over x, let's just say this is 1, and this will be 1. And here we'll have negative 1, Down here we'll have negative 1. So we have points 1, 1, and negative 1, negative 1. Okay? So that's our graph. Now, I'm going to draw the same graph. I won't draw it quite over the yellow line. I'm going to double draw it.
Okay, I'll check that, I can reset it.
And now I'm going to use
Yes,
a different scale for this one, where this is not 1 anymore, at least not for the red graph. This is 25,
anything else we need to look at?
and this is negative 25. So when x is 1, this graph has got to be 25, and this graph has to be negative 25. Now, this graph has two different scales. It's not on the same scale as this one, but we can see that we're going to have the point 1, 25 on this graph, right? We're going to have the point negative 1, negative 25, and the graph's going to have this same basic shape. So where's 1? Well, 1 is going to be, if this is negative 6, then 1's about here, negative 1, and 1's about here. So here's 1, here's negative 1. Okay, now if 6 is here, where's 25?
Way above it.
Well, it's going to be about 4 times that. It's going to be about up here, right? I'm going to go ahead and put that point up here. Okay, so the point 125 is going to be about here, where the x-axis just extends on up. And negative 1, negative 25, well, that's going to be down here someplace, right? So I'm going to have a graph that's very close to the y-axis up here, but it's going to come down something like this. Might not be quite accurate, but let's just say that's it. So from here, okay? So here might be our graph of (25 over x minus 3). Halfway makes sense? Okay, it's not a great graph. I probably didn't get the curve exactly right, but the main thing is understanding where our asymptote is, right? Now I just went and cluttered up this graph, but what I'm going to do now is I'm going to move this asymptote over to where x equals 3, because I can take, and it isn't, the graph I drew is not 25 over x minus 3, it's 25 over x. And now the graph of 25 over x minus 3 is just going to be this thing. Replacing x by x minus 3, we shift it to the right 3 units, which is going to give us a vertical asymptote at x equals 3. And a graph that does something very much like this. And similarly on this side. Okay, let's start down here. We come up here. It's going to do something very much like this. Now I could meticulously take several points here and move them over 3 units. But that's a plausible graph. And of course, this is a process you ought to be able to do. Yeah, 25 is kind of a big vertical stretch, but we'll stretch it. Okay? So at least qualitatively, you understand that the graph that we want is going to be a sum of this graph of this graph. Okay? So I'll come over here. And say, okay, here's x equals 3. And here's -6, and here's 6. And here's the graph of y equals x plus 6. And now here is a graph, at least that represents y equals 25 over x minus 3. Okay? Well, for any x value, I've got to add the value of this to the value of this, right? So when I add those values, what happens is I get close to the x equals 3 line, the vertical asymptote of this function. Well, to the values of this function, I'm just adding the value of this function, which is around this much. So what's that going to do? Well, that's going to raise the points of this graph up about this much. So I can do that. I can say, okay, each of these values is going to become this much bigger. So when this one is here, it's going to have to be about up here. And when this one's here, it's going to have to be about up here. Well, you're still going to get an asymptote, but the graph is going to be a little bit higher than this one. Down here, same thing. For points close here to the y-axis, it's not going to make a lot of difference. So I'm not going to draw it on this side, I'm just going to draw it on this side to get the idea. The function is still going to have an asymptote here, because what you're adding here is only this big, but these values get as big as you like them to be. So the function is going to probably come down something like this. It's going to be just a little higher than this graph. Whoops, should have come through maybe here. Okay. Now what happens to the values of this function as we move to the right? Do they get big? Do they get small? Do they stay somewhere in between? If we come out to here, show me with your fingers, what's the y value of this function when x is here? This function here, it's this big, it's this high. There's your y value, right? In other words, if I take x here, project up and over, well, right there is my y value. Okay? If I add this y value to the y value of this one, what do I get? I get something just a little bit higher, just like this. Now, as I keep going to the right, what happens to my y values? Do they get bigger? Do they get smaller? Do they stay positive? Do they go negative? What do?
They get smaller.
They get smaller. Do they go negative? Remember, I'm starting with the graph of 1 over x. And I'm not vertically shifting it. I'm vertically stretching it, but I'm only shifting it horizontally.
Stays positive.
So the graph is going to approach zero as an asymptote. It's not going to go negative because 25 over x doesn't go negative, right? Okay? Because 1 over x doesn't go negative, at least not as we move to the right. So what's going to happen is this graph is going to come down like this, and then it's going to have to turn around and follow this one. Okay? And what happens on the other side here is, well, these points get lifted up about this much when we're close to the axis. So this point might get lifted up to here. And this point might be lifted up even actually a little bit more than so lifted up to a point that's a little above the x-axis. But now, by the time we get over here, this graph is giving us 0, the x plus 6 graph, so we're going to be on this point. I didn't really locate that very well, it's more like about here. Anyhow, the graph is going to then come up like this, turn around. And since this graph is giving us tinier and tinier y values, negative y values, we're going to stay down below this graph, but we're going to get very close to it. So we have a graph that has an asymptote to this straight line. That's called a slant asymptote. Okay, so the graph of this, which is the same as this. If you've done the homework, you know if we multiply and put all this over common denominator x minus 3 and simplify it, it's going to come out the same as this, if I did the division right. Okay? So this red graph is the graph of this function. It has its asymptote at x equals 3 because this function has a vertical asymptote at x equals 3. Okay? But when x is far from 3, this denominator is big, making this small. That's why it got small out here. That's why it gets small over here. So when I add this to this, if x isn't reasonably close to 3, I'm not adding much, so I'm going to be very close to this. Now if x is less than negative 3, I'm going to have a tiny negative value, just like what I've got here, added to the x plus 6 value, which will take the graph a little bit below the x plus 6 graph. Over here, we've got a tiny y value, which is positive though, and gets added to the x plus 6 value, putting this graph a little higher than the x plus 6 graph. Okay? And this graph has a slant asymptote to the y equals x plus 6. To find that slant asymptote, You just about have to do this long division. But it's a pretty easy long division. Now I realize we just looked at long division Tuesday. And because of the way the curriculum's designed, chances are that you don't remember long division from when you saw it in your Algebra 2 course. If you even saw it in your Algebra 2 course, you're supposed to. Okay? So you might not be expert in long division today, but you will be by Tuesday.
I never did look up synthetic division.
What did you say?
I never did look up synthetic division.
Oh, good, good. I thought you were saying something like maybe you tried to use it or something. After you get really good at long division, I don't care if you use synthetic division, as long as you don't do it on a test. I don't want to see it. Don't do it on a test or homework, but if you're doing something else, that's okay, as long as you're good at the long division. Okay? Preferably you would understand how synthetic division is equivalent to long division. It's not hard to understand. But, as I say, it's handy, but it's one step removed from something you would understand, which is long division. I want you to understand where things come from. Okay, do we understand, at least in outline, that this is a linear function, and this is a simple rational function with an asymptote at x equals 3, with a graph that looks like a vertically stretched 1 over x graph, right? Which is basically what we've got here and here, along with the x plus 6 graph. Fair enough? Okay.